And welcome back, and it's the higher plus 5 a day for the 6th of March, and let's just go straight into the first question. Okay, so it looks like we have an index rules question. Now, temptation here is to use the number 4, but I'm going to go back to 2s. Sorry, board jumping. I'm going to go back to 2s because I think 2s are always a little bit safe. It means you don't have to deal with halves or similar numbers. So 16 is the same as 2 to the power of 4, and I'm doing that to the power of 2x plus 3. And 4x is the same as 2 to the power of 2 to the power of x, and 32 is the same as 2 to the power of 5. Okay, so now we need to neaten this up. So the top, or the left-hand side, is going to be 2. Expand the bracket, so 4 times 2x is 8x, 4 times 3 is 12, and then I'm taking away 2x, which is because I'm dividing in the denominator, and that's equal to 2 to the power of 5, which means therefore it must be the case that the indices are equal. In other words, 8x plus 12 minus 2x is equal to 5. 8x minus 2x is 6x. 5 minus 12 is going to be minus 7, which means that x is equal to minus 7 over 6. And that is the first question done. Not too bad at all, actually. Next question. We have similar shapes. The areas of two mathematically similar shapes are in the ratio. So the areas, so what I'm going to do is I'm going to do length, area, volume, and my area is multiplied by 81 over 49, which means my length is a square root of that, so therefore that's going to be 9 over 7, and the volume is a cube of that, so that's going to be 729 over 343. And then what does it want me to do? It wants me to, the length of the smaller shape is 24.5. Oh, actually, so I just need length, don't I? So therefore it's going to be 24.5 times the length scale factor, which is 9 over 7, and that's going to give me 31.5 centimeters. Okay question, but obviously you need to know the technique with the length, the area, and the volume. Next question, and this looks like a bounds question. Great. Sophie estimated the distance between Bristol and Newcastle is about 290, and her average driving speed would be 60 miles per hour. Okay, the key point is she estimated the distance to the nearest 10. So distance is 280, 290, 300, which means the bounds are 285 and 295. And she estimated the speed to the nearest 10, so therefore the speed is 50 to 60 to 70, which means the lower bound is 55 and the upper bound is 65. So I'm basically working out the middle of the up and down limits, if you like. Calculate the lower bound of the time the journey should take. Give your answer in hours and minutes. Okay, just for a bit of a twist. Give your answer the nearest minute. All right. So what we're doing here is we are remembering that speed equals distance over time. And I'm trying to work out the time. So therefore time is equal to distance over speed. Now, if I want the lower bound, so I want the lowest time, so that's going to be the lowest distance divided by the quickest speed. So you will go the shortest distance at a faster speed, you'll obviously get there quicker. So therefore it's going to be the lowest distance, which is going to be 285, divided by the quickest speed, which is 65. Actually, just check my units here. So it's all in miles per hour, okay. So 285 over 65 is going to give me 285 over 65. It says 57 over 13 in my calculator, but I'm going to write down, just so you know what I'm doing, 4.38461538, etc. So that's hours, and I want the answer, calculate the journey in the lower bound time, give you an answer in hours and minutes. So the way I'm going to do that is that's 4 hours. Then I'm going to take away 4 in my calculator, which gives me 5/13, or 0.3846153846. Multiply that by 60 to get how many minutes, and that tells me it's 23.0 minutes, which in other words to the nearest minute is 4 hours and 23 minutes. I will say it's one of these little things that people are quite often bad at, is converting hours to minutes, so make sure you're okay with that one there. Good job. Next one, and final one of today. Calculate the area of a triangle. Okay, so what's clever about this question is the area of a triangle is a half times the sides times sine of the angle in between. But I don't have an angle in between, do I? I do, however, have a side and an angle and a side and no angle. So I'm going to start by working out this angle here that I'm going to call B for no obvious reason. So I can say that sine B divided by the opposite side, which is going to be 9, is equal to sine of 38, so these aren't going to be nice numbers, divided by the opposite side, which is 20, which means that b equals sine minus 1 of 9 sine 38 divided by 20. Calculator out, and that is approximately, so sine minus 1, 9 sine 38 over 20, and that tells me it's 16.084 degrees. Now I'm using decimal places because I need to use that number. Then what I'm going to do, so I know what B is, which means I can then calculate what A is, which is this angle here. So therefore angle A is going to be 180, total angles in a triangle, minus 38 minus 16.084. Now, as a quick aside, I've used the diagram to tell me that this is an acute angle at B. The diagram might not be very good, so I'm making a bit of an assumption here, but I think that's okay because of the way the question is presented. Anyway, if I get my calculator out, so it's 180 minus 38 minus 16.084, and that gives me 125.916 degrees. So that is my angle A, which means the area is going to be half times the side, which is 9, times the other side, which is 20, times sine of the angle in between, which is 125.916. And that's going to give me, so 0.5 times 9 times 20 times sine of 125.916. Press equals, and I've got 72.889, and let's call that 72.9 centimeters. It is in centimeters, yes it is, centimeters squared. And that's today done. Good mix of questions today. I quite enjoyed those questions today. Again, nice index rule to start. That bounds question was tricky but clever, similar shapes we haven't seen in a while, and a good sort of triangle question at the end. Let me know how you did. Do like and subscribe, and I'll see you for tomorrow. Thanks all.